Networks always started yet.
They're always work.
Gonna say,
Which is why we have, hopefully, all end up at
I don't even know when the.
as long as the HR.
if there wasn't money for it, then there wouldn't be jobs.
Honestly, I think it's probably I would want to stay in this area now. And after I graduate, because I have children,
Yeah.
my next year, and I
Yeah.
can't just leave.
Yeah.
But
F5 and Teletech, that will hire quite a few of our grads.
I don't know, maybe it was just because of my non-3, and my not having the degree, but I haven't much in the local area, including Fed and state, which I'm supposed to get out
Not that I've seen.
because better, but nothing, not a thing.
It's a lot of what you can do, and
Yeah,
the numbers will get you the interview. The numbers stop mattering as soon as you have your first interview. It's about how do you hold yourself? How can you show what you know and what you can't do? How can you explain a poor number as there's so many reasons that a poor number
I wish I
comes to
would have
be.
even gotten my first interview to fail at.
Yeah, that's what the numbers.
Yeah, I ended up having to work under the table as a TFE contractor. Not a plus contractor, as a beat nails in.
All right, let's get this process started. Big announcement for today is that we have peer reviews due tonight.
Oh, yeah.
So please make sure you get them in. I know they're becoming a horrid thing to fill out. It's very annoying, but keep in mind that they're a necessary evil. That as soon as I stop requiring peer reviews, half your team stops working. Or pulling their weight because there's nothing to tie the work to a grade outcome. I don't necessarily mean that from a group to group basis, but in general, that is what is the motivation for that. So it's worth the time for you to fill out the peer review, even if it's just a bunch of high scores, because that will keep the team producing at the highest rate that it can.
90% of mine is high scores.
So we also have a design meeting tomorrow. Yeah.
I got a quick question.
Yeah.
So we got our grades for sprint 1, just like from the Discord.
Yeah.
But are we gonna see those in Canvas before they leave the quarter?
Yes,
Okay.
yeah, they need to be, I need to meet with the grader to talk about exactly how that happens, but. Yeah, there should be no further changes to that unless you advocate. So grades in my classes are never final until they're in the grade book, and even then you can come talk to me. The idea of them being posted is the ability for you to say, is there something that the grader missed? Is there something that there's evidence for that you feel like was unfair? If that's the case, come talk to me. I will certainly listen to your argument and either be able to explain the grader's grade so that it makes sense to you and or make an associated change based on your arguments and the validity of your argument. So it's always worth understanding. Even if no change happens, it's worth the time just so that you understand why you got what you got.
We're gonna see like our grade, like how it's reflected, like just like what the grade was on the sprint for the group, or will we see what our?
You will see your individual score. And so that is another way with the grade that's posted there, plus the client meeting score, you will be able to see if there was a deviation from that between that and what is entered on your canvas. That also allows for the security of you don't know what everyone else in your group got if there was a modification to anyone else in your group, which is necessary to prevent bias from your own peer reviews. So you can see how you are doing, you can see the baseline, so you can see if you're doing better or worse than the baseline. But in almost every case, everyone in here is doing at or above that baseline. There will be a number of people in here who are getting a few extra points from that, and very few people who are being curved down. If you are being curved down, it's because I reached out to you. I'm not going to curve down without having reached out to you about that. But yeah, you know who you are at this point. If you have not heard anything, you will be receiving that or higher from what was posted.
Does it help us to grade everyone else in our group?
Not really.
Okay.
Yeah, it would if you could all conspire, and of course. Without me looking over that and saying why, if there's no evidence, if you're grading other people low caused me to have to reach out to those people and those people provided arguments for me, it would circle back to you as saying, why are you rating these people low? It's undeserved. And my goal as an instructor is to make that not worth your time or effort. To try to circumvent the system.
The new AOL?
Other questions? I'll get a study guide to you by Thursday, and that way we can be sure that there's new material to actually cover with this. We'll be covering TDD today, TDD and BDD today, and then we'll be covering APIs next.
When's that exam gonna be?
The quiz is a week from Thursday. So I'll get a study guide to you by Thursday, so that we'll have a quiz a week from Thursday. Because we've had to cover all of these design patterns, I'm behind a little bit of what I historically do. So quizzes 3 and 4 are just kind of pushed back a little bit in the quarter from where they have historically been, but we'll still get to them and we'll be good. I know this class is super busy. I keep hearing from people I'm doing 3 times as much work in this class as I am in any other class, and I feel like that's necessary in a one-off software engineering class, because this is what most of you are going to be going and doing. So this is what's most important for you to know going into a future job and a future interview. I take that very seriously. I'm sorry for current you, future you will hopefully look back and thank me. If not, feel free to reach back out and swear me out, fine too. All right. Anything else before we dive in? Last couple design patterns. I don't even know if it's worth going over template method, but we'll at least do strategy and visitor because those are both important.
We skipping over state?
We did state at the end of last time.
I thought we stopped on observing. Very.
I'm pretty sure we handled state. Did we handle state? I see some nods.
Sorry, then my brain blanked out.
It's hard when there's most of a day's worth of just going over design patterns. I'm pretty sure that I would be zoned out by the end of that as well. That's a necessary evil, but I do recognize that it is an evil.
We never did that in 212 either. We never like went through them all.
Yeah. Yeah, it was in a lot deeper detail, but the ones that were going to be useful for the airline projects, just because they're, yeah, I tried to cover the remaining ones when I taught 212, but I think the slides that I made for that ran out after the most important ones, and then I just kind of covered the rest this way, but I think it's important to know them all for sure. All right, yeah, strategy has to do with, so let's start with the overarching definition here. Behavioral design pattern, designing a family of algorithms, putting each of the families in a separate class, making their objects interchangeable. So you have different algorithms as ways of solving a particular problem, and then you can plug and play those algorithms into the solution to that in ways that kind of like MVC, where your views are interchangeable. This just now becomes, instead of a state that is a user interface, it's more of a behavior that is an algorithm that's swappable. So navigation app for casual travelers, the ways that you could choose to navigate the city: by foot, by bus, by public transportation, like by metro, by car. Each of those would produce a different route or a different path. And you would want the ability, kind of like it's embedded in Google Maps, to you've set the destination and you want to see and be able to swap out the algorithm for calculating the route as you're using different public transportation. So yeah, strategy just says we have an associated route strategy interface, and then we would have the different strategies embedded within that, the different algorithms that all implement that interface. And then the navigator would build a route based on the associated selected strategy from the user. The user selects, I want a road strategy, and so the navigator instantiates the route strategy to be a road strategy, and then builds the route based on how the road strategy builds a route. You could then swap this out as the user says, all right, that looks like horrible traffic, I'll just walk. What is the walk route? And we'll swap out that route strategy for a walking strategy. And then implement that algorithm, give you that route. And it uses the exact same user interface. And can just show you the new walking route versus a driving route. So strategy is also one of the simpler design patterns, but whenever you see that there are multiple possible solutions to a particular problem, multiple algorithmic solutions to that problem, you can build in this strategy interface and make each algorithm's implement that interface, and then they are swap outable as you have composition here between the navigator and a strategy. It just builds the associated strategy into the navigator app. And that way the navigator is only ever using one such strategy, but that strategy is interchangeable. So various strategies, different ways to get to the airport. They each take different amounts of time and cost different amounts of money. And it allows the user now to select the associated strategy that works for them. And you have all of the options built into your application in a way that is easily swappable. In general, you just have your strategy interface, all of your concrete strategies. You have your context, your manager that associates itself with those strategies, composes itself of all of those strategies, and then the client will utilize the context as a user interface and then realizes that with regards to those concrete strategies. What the client does is realized by those concrete strategies, but what it interfaces with is the context. Questions on strategy? One of the simpler patterns. Not as much complexity as there is in a lot of others. I'll brush over template. So you might have a general algorithmic structure and then want to be able to make changes to different steps within that algorithmic structure, instantiating optionality within that. So let's say you have a business strategy and the associated business strategy changes whether you're communicating with the client, whether you're communicating with some other stakeholder, whether you're communicating with a developer. The algorithm for how that text is generated might be changed, but the skeleton of it is the same, but where certain technical terms are used might be swapped out in some case for some other steps. Another example of this would be a data miner. So you generally want to get data out of different file formats. You might want to parse a Word doc for data, a comma separated value file for data, or a PDF for data. How exactly it goes and does that is going to be different, but the overarching algorithm of how to parse the data and how to store that data is exactly the same. The only part of it that changes is how it is looking in those particular files. So we just break this down into its associated steps. And then the template method is going to mine the path. That's the only templated part. That is going to depend on the associated input file format. Then when it does that, it's going to use the associated data miner portion for that. So you're just breaking this down into that. So a typical architectural plan, slightly altered to better fit the client's needs, same thing. A house is constructed the same way, but if we want, instead of a door and a window, to have a garage door opening at that point, then everything else stays the same. We just swap out a template method for that, and then we can implement a template interface and the associated template classes that allow us to further customize this. So whenever you have something that is generally the same large scale process, but there are small modifications to that, you can create a template method for that. And template is not using, sorry, I think I said an interface and I meant an abstract class because the process is going to be an abstract class because there are steps associated with that process. There's no reason for this to be an interface. You can dictate what steps are shared in common between all of those associated concrete classes within that abstract class. And then the template method just becomes the associated concrete classes for those steps. Does that make sense? Questions on template? Does it make sense why this is an abstract class and not an interface? Fewer nods. Do we recall the difference between an interface and an abstract class? Two people raising their hand. Who could use a refresher on the difference between an interface and an abstract class?
So like, is the interface like the contract that's made to the class that implements it?
Yeah, it's kind of saying anything that implements this interface will implement these methods, but there's no actual implementation in an interface. It's just specifying this is the behavior that needs to be defined in order for an object to utilize this interface, to implement this interface. An abstract class allows for functionality inside of that abstract class, but it cannot be instantiated because it doesn't have enough information for a constructor to be called. There are missing pieces, but it's shared in common between all of its concrete classes. So if we say that steps 1, 2, 3, and 4 are the default behavior, even if there is an associated step 5 at the end of that, the abstract class can define steps 1, 2, 3, and 4. And then the concrete class may override some of those steps, but also may define the further functionality that's needed to be able to be instantiated. So as much default behavior as you can have shared in common between all of its concrete children. You cannot instantiate an abstract class. It does not have enough information to do that.
So would they both be at the very first of the public class, would that be extends both
Yeah.
interface and abstract?
A concrete class would, in this case, extend the abstract class, and if it's an interface, almost everything else we've talked about for most of the other patterns has been an interface. You would say implements that associated interface. You can only extend one class, but you can implement an arbitrary number of interfaces in Java. We don't allow for multiple inheritance. If you want to do that and screw yourself over to that level, go use C++. It allows for that, but we can talk about multiple inheritance and why that is something that you might want to allow or might just want to forget exists. Java has some training wheels associated with it. It doesn't let you make decisions that might harm you. So one of those is it doesn't allow you to extend multiple classes because you can get what's called the, what is the black diamond of death? Or just the diamond of death?
Bullshit, because Java makes me want to die.
But yeah, if you have a class that extends two different classes, so extends, and then each of those extend a single class up here, and this method is defined and overridden by methods that are here, and then you here say that I want to extend that method from that, you don't know which implementation, there's ambiguity on that. So as the programmer, you cannot create that kind of situation or your application will crash, given that there is that ambiguity. Java doesn't even let you do that. You can only extend one class, that way there's always a definition to go back to, but C++ has no training wheels whatsoever. You want to segfault your program, you can do that. You want to try to write memory in the operating system, we'll let the operating system tell you no.
Have you ever seen like this one program in C where it's like basically a roulette where like you pick a number and if you guess the number wrong, it just erases system 32.
I've certainly thought about designing games that you make the wrong choice, it deletes your save.
You're the people that they warned me about.
Yep. All right, last one, visitor. This is another boundary-based design pattern. So you have algorithms and you have the objects on which they operate. If you do this in a dependency manner, then you're going to write the algorithm inside of the object. And if you do this in a way that is scalable, you will separate the object from the algorithm on which it operates. And that way you can add new algorithms and you can add new objects and have those algorithms directly plug into those objects. So visitor is what will help you with that separation. All right, develops an app working with geographic information structured as one colossal graph. We want to export that graph into an XML format. So as part of this, we need all the associated node classes that give us an industrial building, a residential building, a commercial building, a building under construction, etc. But the export implementation should not be tied to each of these objects because you would be duplicating that implementation across all of these objects. And then if you wanted to add a new class to that application, part of the construction of that class would be defining or redefining what it's like to export that new class in XML. So you want to separate that and make an export visitor that has associated methods of how it is going to operate on each of those classes. And that way, when you add a new class, all you have to do is add a method to the export visitor rather than re-implement everything from scratch and copy and paste all of that logic from the export visitor into the class that you're making. So, yeah, real world analogy. Good insurance agent is always ready to offer different policies to various types of organizations.
So is it like finding something that's specific, that's like being multi-purpose, but still fitting?
Yeah, so think of it like training the individual to, here is your general sales pitch techniques. Separating the sales pitch techniques from the exact pitch of when you go to a house selling medical insurance. There are still general techniques that sales pitch techniques that you're going to use. Rather than duplicating the sales pitch technique in the class for the code class that designates, here is how you pitch medical insurance to a residential building.
So let me see if I got this right.
Yeah,
So basically what you're saying is it's kind of like a salesman, where the actual art of selling, so to speak, is still the same, but what they're
Right.
offering is different.
right.
And so it influences the approach.
Yes. So you're gonna factor out the approach part of it into its own separate methods, keeping the sales pitch logic that would be copied and pasted if these were embedded inside of the medical insurance sales class, the theft insurance sales class, and the fire and flood insurance sales class. All of that sales pitch logic would have to be duplicated to do that. And instead, we're going to have one instance of that, methods for how the insurance gets sold. And then we separate it from the classes and then compose those classes of it.
Does that connect back to writing dry code? Don't repeat yourself.
Yes. I don't know, a lot of this is the case for that. It's scalability through not having to repeat yourself. Because now, how many places are there to change when your sales logic changes? Let's say, yeah, there's just one place to change that. Yeah, if you have a bunch of different classes that implement exactly the same copied and pasted logic, now you have as many classes as there are to make sure you go and change that. Who's to say that all of those are done in exactly the same way? You have so many opportunities for bugs to arise just because they weren't changed the same way. One of them wasn't changed. One of them was changed when the others weren't. Lots of problems. So you will utilize something like this structure, a visitor structure. Visitor interface, concrete visitors. The client will go through elements and visitors in order to be able to do that. We separate the algorithmic process from the associated implementations. Questions on visitor? It's often just scalability. It really breaks down to scalability.
Seems like it's really similar to Bridge, except for instead of object creation, you just,
Yeah.
build methods.
Yeah, a lot of these are similar ideas, just broken into different parts of the code, exactly, object construction versus algorithmic implementation. Yeah, they all adhere to things like the single responsibility principle. So go research your solid principles. If that wasn't something that you saw in 212, make sure that you know solid principles, code smells. One thing that I would like to do in a sequel to this course is talk about refactoring. And we don't really get a chance to do this much, but keep in mind that if you didn't see these in 212 or you did see these in 212, it's worth knowing all of them. So code smells, how to write code that is not good. You have your bloaters, your object-oriented abusers, change preventers, dispensables, couplers. Know things like this for what to avoid doing in your own code. And then refactoring is techniques for how to, when the client changes things for you, how do you go about making those associated changes? And if you have applied design patterns to the appropriate places in your code, then adhering to these refactorings are going to be easy and straightforward. And if you have not put design patterns where they should go in an object-oriented approach, going through a refactor like this will be tedious, annoying, and frustrating. So composing methods, moving features between objects, organizing data, simplifying conditional expressions, simplifying method calls, dealing with inheritance. So all of this is something that I would look at on your own time before going into an interview. This is kind of like doing leak code or cramming leak code. This is probably as important, if not more, in an object-oriented style interview. This source is wonderful for that. Again, just refactoring.guru. Make sure you read all of this and refresh yourself on all of this before trying to pitch yourself. Any last questions on design patterns? Because this is probably the limit of how long I have to cover them. I know I have not done them justice. I tried to be upfront about that when we began. There is going to be a lot of outside of class research, but I'm trying to have you implement some of them in your code as we go so that you get some experience with it. It won't be enough. You will need to do more. I'm sorry that I don't have more time to do more with you. All right. Let's talk test-driven development. As usual with a lot of these slides, I will be going through some things faster, and some of that is just due to we've talked about it before. So we talked a lot about Agile. We know about Agile at this point. We're implementing it, we're doing it. Every 1 to 2 weeks, we have a new build that we are giving to the client. We're through 2 of those and working on our 3rd one. But the big picture of behavior-driven design is a lot of what we're doing with Agile. We're developing user stories. Then we are going from user stories to scenarios to tasks. And that allows us to create acceptance tests and integration tests directly from our user stories and scenarios. So that is behavior-driven design. Test-driven development is making sure that we write tests before we write code. So as we go through the design process, the design that we settle on influences the tests that we write. We can tell whether the application we are going to make will adhere to this design because we can write the test based solely on the design. It's implementation independent. So write unit and functional tests for code before you write the code. Write tests for the code you wish you had, then write the code, And it's likely that it will be easier to throw together the code because you're all on the same page with regards to what the code needs to do. And you have tests that show when you have written the code that adheres to the design. The more and better tests you write for this, the less room for error there is when you go actually implement the code. So these are not different ideas, they can be combined. Using behavior-driven design and user stories, scenarios, and tasks for design, and then for development, going through writing tests before writing code certainly can help with that process. That said, it's really hard to spend a lot of time writing tests before you can even show that you have any product whatsoever. So it's hard to know, when have you written enough tests? You don't know, tests aren't the afterthought anymore, they're the forethought.
Teacher.
So, very old,
The Zoom.
the Zune, anyone remember the Zune brick of 2008?
Yeah.
It turns out that what caused this brick, do people know what caused this brick?
Basically after, wasn't it like something really dumb where like
It's literally this is the code.
it couldn't account for like the new millennium, right?
It was basically a Y2K bug.
Yeah, it was a leap year bug on 2008. Yeah, so the date that the date that the Zune thought it was different from the actual date. And because of how it was coded, it could not operate from that point. So it actually could not even turn on and verify the time in order to launch. So yeah, it would not turn on. Yep. Leap year bug, which is funny. It fixed itself after noon on the following day, but for 12 hours, no Zoom would work. So fun. Yes.
Those are the same picture.
Yeah, right.
I don't see a difference.
Yeah.
Why did it
It's
look
the
like a
same
Nokia?
picture.
Why did that look like a Nokia for a second?
So arguments for TDD, test first code tends to be more cohesive, less coupled than code in which testing isn't part of the coding cycle. If you can't write a test for what you're about to code, then you shouldn't even think about coding. This makes sense. Make sure that you've done the design well enough that when the design comes together, you have code that works and you don't have a significant debugging process to go through. The entire reason to do this is to cut down on your debugging time. If you feel like this isn't going to save you some time, my arguments for you would be collect the data yourself. Start a timer for this sprint, for the amount of time that you are spending implementing code, and keep track of a timer whenever you are fixing code or debugging something that's not working. That can even be a Git issue because sometimes the Git issue stems from a code issue or an issue of the sort. So keep track of that ratio of time that you are spending coding, time that you are spending debugging. Think about taking some of that time that you are spending debugging and spending it as part of the design process instead. And in sprint 4, maybe try to focus a little bit more on the design and actually measure and see how much time you can save by focusing some of that time in on the design steps. So this became popular when industry started to move into its extreme programming where we have daily builds or builds that are out very frequently. We're going through the entire process every week or faster. If you're going to do this, then you're making very small changes to the code. So we should be able to write the associated tests for that very quickly. You should be able to implement the code very quickly, assuming that you have the tests that work. When you have a large code base and you're making a small change to that large code base, there are lots of things that can go wrong when you do that with regards to the entire code base. So if you write the tests first, you can ensure that the functionality that you have there is good before it becomes part of the large scale project. As soon as you introduce a single bug into that large scale process, then it will be found at some later date when someone is interfacing with it, and you'd rather catch it when you're dealing with that small piece that you're adding versus the large, trying to use binary search to say, is it in this part of the project or this part of the project? All right, is it in this part of the project or this part of the project? It still takes a very long time to identify when the size or the scale of the project is much larger.
Question, so for me, I really struggle trying to figure out what a good approach to writing tests actually looks like in that process.
Yeah,
Cause I kind of get frozen with like the structure, what are we exactly testing for? Like, do we model the behavior of the program, then write the test, you know, like, what's that gonna look like?
yeah. So if I'm going through a design process myself, first thing I'm thinking about are the requirements. Going from the requirements to what is it like from the user's perspective to use this? If I'm playing the user's role, what makes a lot of sense for a workflow? And then I design the workflow based off of the client's needs.
Almost, and so that's kind of what you meant by behavior driven and test driven methods being hand in hand.
Yes, yeah, so you design from there, from the user's experience, and then you say, given my technical knowledge, how do I design a system that efficiently does what the client wants from this? So that will give you a sense of what are the associated data structures and algorithms that we are using. Note that this is still just identifying those data structures and algorithms at this point. We're not implementing those data structures and algorithms. That allows me to see the decision boundaries between the different components. If we need these structures, these algorithms, this functionality, I can start to write a UML for the project as a whole. I get a sense of what is the general class structure, what are the inputs and outputs to these objects, how are they interfacing with each other, what are those needs, and I start to write a list of dependencies of objects to other objects or objects to themselves. When is something going to work? And you start listing preconditions and postconditions. So what needs to be true in order for me to run this method? What needs to be the case once this method is finished? Again, not a single line of code has been written yet, but I have a very good sense of what this code structure would look like in my head, because I've designed that structure starting from the user's perspective and then incorporating technical knowledge of how this is going to run. Your question?
Yeah, so an issue that I often am having with testing is, you know, there might be some sort of method or algorithm that we're planning on using. And so we test for that. But then sometime throughout the process, we realize, you know, we actually want to do this in a completely different way.
Right,
And so now we have to completely refactor our tests for this new way that we're doing it.
right.
Um,
What I would argue is if you're implementing that, that is a very good point. If the design is good, you're hopefully catching that one at the design step. And then two, if you've written tests for it, usually the tests aren't the bottleneck for the difficulty of throwing it together. So it's not as bad to throw away tests as it is to throw away code. And so if you're finding this issue at the design step instead of at the implementation step, if it's equally likely to find them at one or the other, then I would argue that it would be less work overall to throw away the tests once than it is to throw away the half implemented design, the half implemented code once. That said, people do disagree on this. So I'm not necessarily saying this is the only way to write code. It will be dependent on the project. It will be dependent on your coworkers. It'll be dependent on many factors outside of that, but it's more complicated than just this is the right way. This is just a way to consider.
You said several times that you're using your technical knowledge to figure out how you're taking these behaviors and making tests for them, but we kind of have limited technical knowledge.
Sure, fair. So like early on in sprint one, a lot of people decided on using hash maps rather than lists for their internal structural representations. And that was a very solid idea because hash maps have logarithmic time access versus lists that have linear time access. So technical knowledge like that, where you have two different options to implement and you have reasons to implement one or the other versus an alternative. So you will also find that if you go through a design process like this first, then the learning outcome, when something does go wrong, will point back to flaws in the design as opposed to flaws in the coding process. We all know how to code at this stage. The issues always stem, I find, from either lack of knowledge of knowing what's available or what's out there, or in mistakes from that leads to the implementation mistake. And then you spend 90% of your time uncoupling that implementation mistake. At least that was the case for me as an undergraduate. I still remember those days. They were not fun. Follow up or further discussion on that? I feel like we could probably discuss that for a while. So that is an important point, that if you kind of lack the technical knowledge, is it really worth going through? But I would argue that it does point back at the design process. So what you learn from your mistake is based on mistakes you made in that design, and that trains you faster to do better. All right, so how would TDD work? Once we have a solid design, I would not start writing tests before you have a design. So your design should be fully fleshed out. You should have talked about this with all of your group members, all be on the same page with regards to a design, be looking at a UML diagram that everyone agrees on, have an understanding of the associated structures that you're going to do, then you would start writing the tests. So you're going to use the user stories and use cases. So we write a test. You can run the tests that you have made. And since you haven't written any code yet, they should obviously fail. If you have a test that succeeds, even though you haven't implemented this new functionality yet, that is very strange. There may be an issue with your test. There may be an issue with that is very strange. You don't want to have written the code incorrectly and the test passed before you even started writing the code. And then you run the test and you're like, wow, it passes. Great. I must have implemented it correctly. So if you just very quickly run it, ensures that it doesn't pass, that's good. That way, if it passes in the future, you know it was because of what you implemented. Then you go write the code, only the code that is designed to pass that particular test. No additional functionality. And then you run the test again. And you see that all of your tests, including the new tests, now pass. And now, according to the standards that have been identified by your team, that is the tests that you have written, the code meets that standard. Once that's the case, then you would open up a code review, some kind of pull request that actually says, all right, let's implement this, incorporate it, and now clean up the code and make sure that it's readable, professional, and ready to go. Then rerun your tests one more time, making sure that by cleaning things up, you didn't break functionality. Then write your next test. So it doesn't say write every single test before you write any of your code. It's more of a start writing tests and then write the implementation only for what that test covers. Here's kind of a workflow for test first versus test last. It's just a matter of where does the writing a test happen. If you test first, then you write it after you pick the functionality, and then you write the test, and then you write the code. Otherwise, you write the code, and then you write the test. Logically, look kind of like this. We can see that when we add less with regards to a single test, there are again fewer failure points, and you're not trying to implement more than a small test or a couple of tests for a piece of functionality. If you break your program down into those smaller pieces of functionality, then you'll find that it's easier to test, debug. It will overall be less work if done well. So to validate this, let's take a look at a couple of research studies. So 3rd-year undergraduates, 8-week intensive Java course, learn testing with JUnit, basic design concepts, object-oriented programming, 2 groups, a control group and a test-driven development group, each developed a bowling game. And then we looked at, it wasn't including me, they looked at the test first programmers wrote more tests per unit of programming effort. So per line of code, there were more tests written for their application than if they tested last. Testing last seems kind of like what tests do I need to write to ensure the functionality that I already know is there? Versus if you do the test first, you're thoroughly exhausting the tests. And that is better in a large scale integrated project because there are lots of moving parts. You can easily write a new piece of code that breaks something all the way on the other side of the project. So having more tests is better for that if they are well designed. The test first programmers produced higher quality programs. They had fewer bugs in them. So there was better quality, there was better productivity. And that was good. That's saying. Yeah, the quality was approximately the same, it actually looks like, but the productivity, the students who wrote the tests first better understood their code, had better task focus. So if you were asked at a particular point, what are you working on? They had a better ability to relate that. They were able to learn a bit faster, had lower rework effort. So how much did you actually have to go back and do when something did not work? There was less bug fixing in that. Wrote more tests, as we said, and led to higher levels of productivity overall. Study number 2, pair programming, again, 2 groups, same thing, same authors, developed a bowling game. TDD would yield code that's superior to developed, waterfall developed code, developed code faster. The TDD code passed about 18% more test cases than the control groups. Took approximately 16% more time than the control groups. So in this case, it did actually take more time to write the tests first. Then research number 3, doing this at an industry level now rather than an undergraduate level. So we were looking for defect rate, productivity, test frequency, design and integration. And was found at IBM that there was about a 50% reduction in defect density. So errors per 1,000 lines of code before TDD and after TDD. Productivity was below the estimate, which is, you can see that it's probably somewhat more work. But then they had more tests and the functionality was better in the end anyway. So I guess we will come back to this on Thursday. And we'll finish up talking about this. We're most of the way through already. But we will finish this and we will start talking about API design, which is another of the most important concepts that we cover in this class. Because APIs are kind of important.
What is it? Not plates, is it? Amazon's.
Yeah.